So good day, class. Today we're going to be talking about the clocked JK flip-flop. This time it's active low asynchronous input. So what is this? We know what active low is already. It means it can only perform its function when it is low. That is what active low means. Now, in this case, the asynchronous inputs in this case are preset and clear. Those are the two asynchronous inputs we have in this particular flip-flop, and they only function when they are low. So you see that now. Now I'm going to explain how asynchronous inputs work. Asynchronous inputs, right, preset and clear in this case, they do not care about the J and K inputs. So basically they override the J and K inputs. So now you can see at this point this is a normal JK flip-flop using the NGT. In this case, that's the negative going transition of the clock to function, and it's the same table when J is 0 and K is 0. Q has no change. When J is 0, K is 1, Q is 0. The same normal JK flip flop we know. Now you can see once in this case, you're noticing that pre and clear are all 1 and 1. So when pre and clear are 1 and 1, it depends on the J and K inputs. But once pre and clear begin to have different values, you remove, or rather in simpler words, you don't care about the J and K input. So now we can see here free and clear when it's one on one, there's no change. I'll explain that in the example we're going to treat. It is not contradicting what we have here. I'll explain that in the example. And when pre is one, the function of pre is to set q to 1, and the function of clear is to set q to 0. And now since this are active low, pre can only perform its function of setting q to 1 when it is equals to 0. And in this case, clear can only perform its function of setting q to 0 when it is 0. So look at this table. When pre is 1, clear is 0. Clear is 0, that means it will perform its function. It sets q to 0. You can see here pre 0, clear is 1. Pre set is at 0, that means it will perform its function of making q1. So that's how asynchronous inputs work. Now let's go to an example. So now since pre and clear are asynchronous inputs, that means we only depend on them for the circuit unless at certain conditions. But we'll first draw our lines at the changes in pre and clear because that's where we are concerned with. Now next, there are some times when pre and clear become 1 and 1, and therefore you have to start depending on the J and K values. So, and the J and K values are dependent on what? The clock signal. So we're also going to draw lines at the negative, that's the NGT, negative going transition of our clock. This is the NGT, and we'll only use this sometimes. We'll mostly be dependent on pre and clear. So this is how you're going to draw out your lines. Now let's go to another example. Okay, so this is what we're going to have. The yellow bars represent for the NGT, while the black represents for the pre changes in pre and clear. So let's start drawing our output waveform Q. I'm going to change the color of my pen. So assuming Q is initially 1, we're going to stop at the first NGT we see here. So now at this NGT, what do we see? Pre is here, like I said, we're only concerned with pre and clear. That's all we're concerned with for now. So now we can see pre is 1 here and clear is also 1. And when we come to the table here, we see it here, right? But notice that we are at an NGT, which means we can use what we see here instead, because here is not concerned with the clock, but we are currently at an NGT. And so now we're going to use our J and K values. What is our J and K giving us? 1. So J is 1, K is 1, and therefore our output Q will toggle. So we're going to toggle Q here. Let's toggle it till we get to the next signal change. So now at this point we see that pre is 0 and clear is 1. That means we're going to follow this on the table. So Q is going to become 1. going to stop at this point. Now at this point, there's a new signal change. Pre is 1, Q pre is 1 and clear is 1. At this point, we are not at an NGT, so we are free to use this because we are not at an NGT. That's A at the clock signal, negative going transition clock signal. So Q will remain unchanged till it gets here. Now pre is 1, clear is 1, right? You may want to use here, but notice that we are at an NGT at this point. So we can use this instead. And we know here our inputs are J is 1 and K is 1. That means Q will toggle. As Q is 1, it comes. Now at this point, we can see that pre is 1, clear is 1. You can use this if you want, but notice that we are at an NGT. So instead, we're going to use this. We know our J is 1, K is 1, so Q will toggle. Toggle is a 0, now to come 1. Now, next here we have that pre is 1, Q is 0. So we find out that here. That means Q become 0. So we're going to toggle it down. Not toggle, bring it down to 0. I'm going to stop at this point to see if there's any change. You can see pre here is 1. It's a very narrow gap. And clear here is 0. That still follows this rule. So Q will still remain 0 till it reaches this point. Now at here we see pre is 1 and clear is 1. That means we are allowed to use this, but let's see, are we at an NGT? You can see that we are currently not at an NGT. So we're going to use this instead. We're just going to no change. So it's going to remain 0 to reach this new spot. This is an NGT now. Let's see what is the values for pre and clear here. Pre is 1, clear is 1, which means you can use this if you want. But let's see, are we at an NGT? Yes, we're at an NGT. So instead, let's use this. So you're going to toggle up and go final answer. So this is the final waveform for this particular flip-flop. I hope you understood the concept of active low asynchronous input. Thank you for listening.